Hey all, welcome to the first video lecture for Calculus 1. I'm your instructor, Dr. Scott Spaniel, and so we're going to go and get started. You should be able to download the note sheets for this chapter from my math lab under the handouts page on my math lab, so you should go ahead and do that. If you haven't done so already, pause the video, do that first so you have something to follow along with and take notes. If you don't have access to a printer or some way to print that off, or a device that you can take notes on with it as a PDF, feel free to just take notes on any piece of paper. So at this point, go ahead and take out that handout and we'll get started with today's lecture. So chapter 2 is where we're starting out in this class. So chapter 1, if you want to look back at it, is just a review of topics from college algebra and college trig that you should have already seen. So I've decided to just start with chapter 2. And we're going to talk about limits and continuity. So the idea in this chapter is we're building up the basics of what we need in order to be able to do integrals and derivatives later on in this class. Okay, so we go and turn to page 2 here. We can go ahead and start talking about this. So the first thing we're going to look at is the idea of rates of change and tangent lines to curves. This is the basis of what's later going to be used to talk about the derivative in chapter 3. So given a function y equals f of x, we calculate the average rate of change of y with respect to x over the interval x sub 1 to x sub 2 by dividing the change in the value of y. So this little symbol here is the Greek letter delta, and it just stands for change. So the change in y is simply y sub 2 minus y sub 1. And then we divide by the length of delta x, so the change in x. So x sub 2 minus x sub 1. Okay. So we're going to divide those over the interval in which the change is occurring. So the definition of average rate of change, this blank is delta y divided by delta x. The average rate of change of y equals f of x with respect to x over the interval x sub 1 to x sub 2 is delta y over delta x equals f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, or that's the same thing as saying y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Yeah. So geometrically, the rate of change for f over x sub 1 to x sub 2 is the slope of the line through the points P and Q. In geometry, a line joining 2 points of a curve is called a secant line. Thus, the average rate of change of f from x sub 1 to x sub 2 is identical to the slope of the secant line PQ. So you may have recognized this formula already for average rate of change, but it is exactly the same formula we use for the slope of a line. So to find the average rate of change of a function over a given interval or intervals, what we want to do is we simply want to find these f values, find the y values that go with the interval, and then plug them into the formula. So in this case, we can find f of 4 and f of negative 2. So f of 4 would just be negative 4 squared minus 2 times negative 4, and f of not negative 4, positive 4. And then negative 2 squared minus 2 times negative 2. Okay. So that's 16 minus 8, so that's 8. And this is 4 plus 4, so that's also 8. So for that one, we get 8. And so then to find the average rate of change, delta y over delta x, we take f of 4 minus f of negative 2 over 4 minus negative 2. So that would be 8 minus 8 over 4 plus 2, which is 0 over 6, or 0. Okay? And so that's the idea. That's what we're doing here. Okay? So same idea for the second one, right? Yeah, I just need to plug these numbers in. So we can start out by finding h of pi over 2 and h of pi over 6. Okay, so these are simply going to be same idea as what we were looking at before, but now we're using trig functions. So this is the cotangent of pi over 6 and the pi over 2. And the cotangent of pi over 6. So you could do these in a number of different ways. You could try using a calculator, and that would work out for some of these, although if you get a decimal, it may be an irrational answer. But we can do these by hand as well. So this is the cosine. You can rewrite this as the cosine of pi over 2 over the sine of pi over 2. And this one would be the cosine of pi over 6 over the sine of pi over 6, right? So that's just using trig identity. Cotangent is cosine over sine. And the reason we change it to cosine and sine is because those are easier ones to remember than trying to remember all the trig values. So the cosine of pi over 2 is 0. Sine of pi over 2 is 1. Cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2. And so we get 0 and root 3. Okay. And now we can do the same thing we did above, right? We can plug this into the formula. So this would be delta y over delta x would be h of pi over 2 minus h of pi over 6 over pi over 2 minus pi over 6. Now we can plug in the values we found for h of pi over 2 and h of pi over 6. So 0 minus root 3 over pi over 2 minus pi over 6. And so on top we get negative root 3. On the bottom we're going to need to get common denominators. So this would be 3 pi over 6 minus pi over 6. So this would be, now we can come down a line here, negative root 3 over 2 pi over 6, which is negative pi over 3 over pi over 3. And so that becomes negative root 3 times the reciprocal. So this would be negative 3 root 3 over pi would be our average rate of change. So things get slightly more difficult when we start dealing with trig functions just because of the fact that we're talking about a lot of irrational numbers. Okay. So at this point, what I'll ask you to do most of the time is pause the video and try these two problems. So if you've got the note sheet out following along, you can do it on there. If you don't, you can just use a scratch piece of paper, but same idea as what we did before, but try these two. Okay, now that you've had a chance to try these two, let's go ahead and go through these together. So first thing, right, is find f of 1 and f of negative 1. So f of 1 in this case, it's 1 cubed plus 1, which is 2. And down here it'd be negative 1 cubed plus 1, which is 0. So delta y over delta x is going to be f of 1 minus f of negative 1 over 2 minus, over 1 minus negative 1. So that's 2 minus 0 over 1 plus 1. So that's 2 over 2, which equals 1. So in this case, the average rate of change is 1. And then for the last one, same idea. So find g of pi and g of the opposite of pi. So that would be 2 plus the cosine of pi and 2 plus the cosine of negative pi. So the cosine of pi is negative 1. So it would be 2 plus negative 1. And the cosine of negative pi is actually also negative 1, so this would be 2 plus negative 1. So in this case, we get 1 and 1. So this would be delta y over delta x equals g of pi minus g of negative pi over pi minus negative pi. So that would be 1 minus 1 over pi plus pi, which is 0 over 2 pi, which is just 0. So for that one, we get 0. Okay? So that's the idea. So that's the average rate of change formula and how you use it. Now, on page 3, what we want to do is we want to take this a step further, and we want to start defining this idea of the slope of a curve, using this idea of secant lines and then taking it further to the idea of tangent lines. So the slope of a curve is defined by the slope of the line tangent to the curve if one exists. A tangent line is a line that grazes the curve. We define the tangent line at a point on a curve by analyzing the behavior of secant lines that pass through P and nearby points Q as Q moves towards P along the curve. We then compute the limiting value of the secant line slope as Q approaches P. If the limit exists, we take this to be the slope of the curve of P and define the tangent line to the curve P to be the line through the point through P with this slope. Okay. So the idea here is if I had a curve, so let's just draw a curve, and here's my point P, then there should be some line that just barely grazes that just touches at P. And the idea is, if we find points Q and we find the secant lines between P and Q, the closer we make Q get to P, the closer it'll get to the tangent line. And so that's what we're going to try and do here. Okay? So the idea is to use the formula and see what happens if P and Q, the distance between P and Q actually becomes 0. So what we can do here is we can use a different formula for this the curve, which I haven't written, but I'm going to go back a page real quick and add it on here. So another way to look at this is I can also write this formula if I define H to be delta x. So that means H is the distance between x sub 2 minus x sub 1. Then what happens is this formula becomes f of x sub 2. Oh, sorry. Let's see. F of x sub 1 plus h minus f of x sub 1 over h. Okay, so this is another way to look at this formula. So we can throw in another variable here, and now we're only dealing with one of the points. Okay, and so that's the formula we can use here to think about what's happening and to find these slopes. So for example, here, if I were to plug this into the formula, what it would look like, right? The standard formula is this: delta y over delta x equals f of x sub 1 plus h minus f of x sub 1 over h. Okay, and so what we're going to do now is substitute in the information here. So let's start by substituting in x sub 1. So x sub 1 is 2. So delta y over delta x equals f of 2 plus h minus f of 2 all over h. Okay, and now we can substitute those into the function. So this would be delta y over delta x equals 7 minus 2 plus h squared minus, and now here we could plug in 2 into the function, but if you do, what you should notice is you get this y value, right? So that's going to be 3 over h. Okay, and so now what we're going to do is try to simplify this. Okay, so delta y over delta x equals 7 minus, I multiply 2 plus h out, and that's 4 plus 4h plus h squared minus 3 over h. Now we can come up here. So delta y over delta x equals, distribute the negative, so 7 minus 4 minus 4h minus h squared minus 3 over h. And now we can simplify further. 7 minus 4 minus 3 is 0, so those all go away. So we get delta y over delta x equals negative 4h minus h squared over h. And then we can divide both of those by h, and we get delta y over delta x equals negative 4 minus h. And now the question is, what happens if the distance between P and Q becomes 0? So what if h were 0, right? So if h were 0, then delta y over delta x would be negative 4, and so that is our slope, m. Remember, m is the letter we use for slope. And so now that we have a slope and a point, we can find the equation of the tangent line using point-slope form, which if you remember from college algebra is y minus y sub 1 equals m times x minus x sub 1. Okay, so in this case, our y sub 1 is our y-coordinate of our point, so this would be y minus 3 equals our slope, which is negative 4 times x minus the x-coordinate of our point, which is 2. And now we just solve for y. So y minus 3 equals negative 4x plus 8. Add 3 to both sides, and we get y equals negative 4x plus 11. So there are two parts that two answers to this equation. What is the slope of the line, and what is the equation of the line itself? So that's what we're looking for here. Okay, so at this point, go ahead and let's try another one together, and then I'll have, well, I think we'll go ahead and try 2 more together, and then we'll have you pause the video and try one on your own. So that one was a polynomial. That's a quadratic equation we're doing. Here, now let's talk about a rational equation. Okay. So for this one, start out exactly the same way. So this is delta y over delta x is going to equal f of 4 plus h minus f of 4 over h. Okay. And now we can plug those into the function. So this would be 4 plus h over 2 minus 4 plus h minus f of 4. Well, f of 4 is negative 2 over h. Okay, and so now we can do some simplifying. So delta y delta x equals 4 plus h over 2 minus 4 is negative 2 minus h plus 2 over h. And so now what we have is what we call a complex fraction, right? We have a fraction within a fraction. So the way you deal with fractions within fractions is you multiply by the least common denominator. So that least common denominator is this piece, right? That's the only denominator within the bigger fraction. So that's our least common denominator. So we're going to multiply by negative 2 minus h over negative 2 minus h. So on top, you're going to want to distribute. So negative 2 minus h times this first fraction, the negative 2 minus h is canceled, so we just get 4 plus h. And then over here, we're going to distribute. So 2 times negative 2 is negative 4. 2 times negative h is negative 2h. Sorry, I did that wrong. 8, no, that's right. Yep, negative 2h over h times negative 2 minus h. Okay. Now don't multiply this bottom part out because we're going to simplify a little. So now we can combine like terms. So these cancel. And I think I'll just come up here at this point. So delta y over delta x equals h minus 2h is negative h over h times negative 2 minus h, and now I can cancel out an h. So delta y over delta x equals negative 1 over negative 2 minus h. Okay, so now that we've simplified it down as much as we can, what we want to do is we want to substitute in h again. We want to let h equal 0. We now want to make the distance between p and q be 0, and h is that distance. So I can substitute that in. So delta y over delta x equals negative 1 over negative 2 minus 0. So delta y over delta x is positive 1/2. Okay, and so that, once again, is our slope. So now, just like in the previous problem, I can take my slope and my point, plug it into point slope form, and get the tangent line. So y minus y sub 1 equals m times x minus x sub 1. So in this case, our y coordinate is negative 2, our slope is 1/2, and our x coordinate is 4. So this is y plus 2 equals 1/2 x minus 2. Subtract 2 from both sides, and you get y equals 1/2 x minus 4. And so there is the slope of the line tangent to the curve at that point. Okay, and when you're dealing with rational equations and trying to find these tangent lines, this step right here of having to multiply by the least common denominator over itself is very common. That's a very common step you're going to need to use there. Okay, and now let's go and look at the last problem on this page. So here's one with a radical expression, one that involves a square root. The setup is exactly the same, though. Nothing changes with how you set it up. There's the step that's going to be different is later on in the problem. So this is f of negative 2 plus h minus f of negative 2 over h. So delta y over delta x equals the square root of 7 minus negative 2 plus h minus f of negative 2, which is 3. Simplify inside the square root. So delta y over delta x equals the square root of 7 plus 2 minus h minus 3 over h. And then delta y over delta x equals the square root of 9 minus h minus 3 over h. Now, one of the things I've kind of been skipping over as we've been doing these is this looks simplified, and it is. In the other two cases, we were able to simplify further and make the problem simpler. Here, we can't necessarily do that, but there's still a problem. If I try to let h equal 0 right now, well, what happens? Well, the denominator is 0, and that's a problem because we cannot divide by 0. So what we need to do is we need another way to write this. And so what we do is what's called rationalizing the numerator. And so the way you do that is you multiply by the conjugate. So the conjugate is simply the same expression that's on top, except this minus sign becomes a plus sign. And if that had been a plus sign to begin with, it would have become a minus sign. So this would be the square root of 9 minus h plus 3 times the square root of 9 over the square root of 9 minus h plus 3. Now the reason that's useful is what happens when you multiply by the conjugate. Well, we FOIL, right? So the square root of something times itself, the square roots cancel, so that's 9 minus h. And then notice I'm going to get a negative 3 square root of 9 minus h. And, for the first time, I'll go ahead and write this out. So I get negative 3 times the square root of 9 minus h plus 3 times the square root of 9 minus h. And then I get negative 3 times positive 3, which is minus 9. All over h times the square root of 9 minus h plus 3. Now, notice what happens here, and this is why we multiply by the conjugate. These two terms in the middle here are opposites. So the only two terms with radicals in the numerator left cancel each other out. Okay, so we can cancel those two out, and that's going to get rid of all the radicals in the top. So this will be 9 minus h minus 9 over h times the square root of 9 minus h plus 3. Now the 9's cancel because 9 minus 9 is 0. So this is delta y over delta x equals negative h over h times the square root of 9 minus h plus 3. And now the h's cancel. So this is delta y over delta x equals negative 1 over the square root of 9 minus h plus 3. And now we can let h equal 0. And if we do that, we get negative 1 over the square root of 9 plus 3 square root of 9 is 3. 3 plus 3 is 6. So this would be negative 1/6. Okay, so there's our slope. And so now we put it into point slope form. Our y-coordinate is 3. Our slope is negative 1/6. Our x-coordinate is negative 2. So this would be y minus 3 equals negative 1/6 x minus 1/3. Add 3 to both sides. And you get y equals negative 1/6 x plus 8/3. Okay. And so that's the idea. Those are the 3 basic types you're going to run into in this section and how to deal with them. So at this point, you can go ahead and flip over to the next page, pause the video, and try these 3 problems. So if you don't have the notes here, go ahead and write them down, what the 3 problems are, and then try them. If you do, now notice I went ahead and gave you polynomial ones for all of these, so these are going to be a little more straightforward, more like the one we did before, just with some more complicated multiplication. So go ahead and pause the video and try these. Okay, so now that you've tried these, let's run through them together. So for the first one, it's delta y over delta x. So that's going to be f of 1 plus h minus f of 1 all over h. So f of 1 plus h, we plug that in for x. So that's 1 plus h squared minus 4 times 1 plus h minus f of 1, which is negative 3 all over h. Multiply these out. 1 plus h squared is 1 plus 2h plus h squared. Negative 4 times 1 plus h is negative 4 minus 4h plus 3 all over h. And now combine like terms. So 1 plus negative 4 is negative 3 plus 3 is 0. So that cancels. So 2 plus 4h is negative 2h and h squared all over h. Simplify. Delta y over delta x equals negative 2 plus h. And now let h equal 0. And we get delta y over delta x equals negative 2. Okay, and so now we plug it in point and slope form. So that's y plus 3 equals negative 2 times x minus 1. So y plus 3 equals negative 2x plus 2. So y equals negative 2x minus 1. Okay, so that's the idea. That's what we're doing here. So let's go ahead and look at the last two. And the trickiest thing about the last two is the fact that we have x cubed, which means the multiplication is a little more difficult. So in the first one, it's delta y over delta x equals f of 1 plus h minus f of 1 all over h. So delta y over delta x equals 2 minus 1 plus h cubed minus f of 1, which is 1, all over h. So this is 2. Now I can multiply this all out, so it's minus 1 plus h cubed is 1 plus 3h plus 3h squared plus h cubed minus 1 over h. Distribute the negative. So delta y over delta x equals 2 minus 1 minus 3h squared minus h cubed minus 1 all over h. 2 minus 1 is 0. So we get delta y over delta x equals negative 3h minus 3h squared minus h cubed all over h. So delta y over delta x. Divide each of these terms by h, and you get negative 3 minus 3h minus h squared. Let h equal 0, and delta y over delta x equals negative 3. So the slope of our line is negative 3, and so we plug that into the point slope form. So y minus 1 equals negative 3 times x minus 1. So y minus 1 equals negative 3x plus 3, and then add 1 to both sides, so you get y equals negative 3x plus 4. Okay. And so that's what we're looking for. And so now finally the last one here. So delta y over delta x is going to equal f of 2 plus h minus f of 2 all over h. Delta y over delta x equals, plug in 2 plus h into the function, so 2 plus h cubed minus 3 times 2 plus h squared plus 4 minus f of 2. Well, f of 2 is 0, so minus 0 all over h. So delta y over delta x, 2 plus h cubed is 8 plus 12h plus 6h squared plus h cubed minus 3 times 2 plus h squared is 4 plus 4h plus h squared plus 3. Plus 4 on the end. So that just comes along. Now distribute the negative 3. So this is 8 plus 12h plus 6h squared plus h cubed minus 12h minus 12 minus 12h minus 3h squared plus 4 all over h. Combine like terms. So 8 minus 12 is negative 4, plus 4 is 0. 12h minus 12h is 0. 6h squared plus minus 3h squared is 3h squared. And then plus h cubed over h. So this is delta y over delta x equals 3h plus h squared. When we let h equal 0, that gives us delta y over delta x equals 0. So the slope of this line, in this case, is 0. So now we plug in those into the equation. So y minus 2 equals 0 times, not 2. Y minus 0, our y coordinate, right, is 0. So y minus 0 equals x, 0 times x minus 2. So y minus 0 is y. And 0 times anything is 0. So y equals 0 is the equation of our tangent line. Okay. So that's the idea. That's how this works. Now, so we can take this a little bit further and talk about this in application form. So the accompanying graph shows the total amount of gasoline A in the gas tank of an automobile after being driven for T days. Estimate the average rate of gasoline consumption over the time intervals 0 to 3, 0 to 5, and 7 to 10. So to do that, we're just using the average rate of change formula, right? So we just need to find the points at 0, 3, 5, and 7, and 10, right? So at 0, that's that point. So that looks like 0, 15 to me. At 3, that looks like 3, 10. At 5... that looks like it's a little bit about halfway, so I'm going to call that 3.5. And at 10, oh, whoops, I forgot 7. 7 looks like it's 7, 1.5. And 10 looks like it's 10, 0. Notice each one of these tick marks is 2, right? 0, 2, 4, 6, 8, 10. So that's, when we're on a tick mark, we're at an even number. When we're halfway between two tick marks, we're at an odd number. And when we're a little bit more or a little bit less than that, we're going to be at a half, right? So that's where these decimals come from in those two. So to find the average rate of change from 0 to 3, I just take y at 3 minus y at 0, and then 3 minus 0. So this would be negative 5 over negative 3, which is, negative 5 over positive 3, which is negative 1.667. So the average rate of gasoline consumption over those first 3 days was negative 1.667 gallons per day we're using. Okay. So for the second one, same idea, except now I'm going from 0 to 5. So it'll be 3.5 minus 15 over 5 minus 0. Right, so that's 3.5 minus 15 is negative 11.5 divided by 5. So that's negative 2.3 gallons per day. And the last one from 7 to 10. So at 10, our y value is 0 minus our y value at 7, which is 1.5, over 3 minus 0. So that's negative 1.5 over 3, which is negative 0.5 gallons per day. Okay, so then that's the idea. So then to find to estimate the instantaneous rate of gasoline consumption at a point, that means we want to look at the slope, right? We want to of the tangent line, not the secant line. So these were finding the slope of the secant line. So for example, if we take if we look at 1, for example, what we could do is we could look at, well, what's happening to the slopes as we get closer and closer and closer to that. Okay, so for example, we could go from 1 to 3, and we could go from 1 to 2, and if we wanted to, we could even go 1 to 4. So we could look at 3 of those, and we could look at the pattern as we get closer. So if I was doing this for, I think we won't do it for all 3, but let's do it for at least 1. So if I was doing this for t equals 1, what I could do is I could go from 1 to 4, 1 to 3, and 1 to 2. Okay? And so if we go back up to our picture here, we have to estimate these points. So at 1, it looks like it's 1 comma 14. At 2, it appears to be 2 comma a little bit more than 12. So I'm going to call that, but not quite 12 and a half. I'm going to call, well, let's call it 12 and a half. That'll work. We already have 3 comma 10, and if we go down here, we can see we have 4 comma 6. Okay, so you want to do each one of these, delta y over delta x. So from 1 to 4, we start with the y coordinate of the last part. So this is 6 minus 14 over 4 minus 1. For the second one, it's 10 minus 14 over 3 minus 1. And for this one, it's 12.5 minus 14 over 2 minus 1. Okay, so we can get each one of those. And the closer we get to 1, the smaller that interval gets, the closer we should be getting to the instantaneous rate of gasoline consumption at 1. So this would be negative 8 over 3. So that's negative 2.333 gallons per day. This next one is negative 4 over 2. So that's negative 2 gallons per day. And then the last one is negative 1.5 over 1. So that's negative 1.5 gallons per day. So we can see it's decreasing, and it's going towards 1. So it's probably its instantaneous rate would probably be somewhere just less than negative 1.5. So I'm going to say it's approximately negative 1 to negative 1.5. It's somewhere in that range. So pretty much any answer you gave in that range would work, would be a good answer. Okay. And then the last thing you want to look for is it says estimate when the maximum rate of gasoline consumption and the specific times it occurs. Well, to do that, we just want to find where is the slope of the tangent line steepest. And to me, that looks like it's happening in this range in here somewhere. So I would probably say it's at about 3.5 days. Right? It looks like that's probably the steepest point. Okay. And if you wanted to, and so that's the idea with doing these problems. And you could guess what it is based on some of the other numbers we've already done. Like we did 1 to 4 was negative 2.337. So that was this line here. And it's definitely steeper than that. So we could say it's more than negative 2.3. So we could probably say it's about negative 3 gallons per day. Okay. And so that's what we're looking at when we're doing application problem with these, is we're trying to find average consumption, average rates of change, and also instantaneous rates of change. Okay. So let's look, if you wanted to pause the video and try this one, you could, and then we can go through it real quick here, and then we'll be done today. So try it real quick, and then we'll talk about it. Okay, so let's run through this problem real quick, and then we'll be done. So the accompanying figure shows the plot of the distance fallen versus time for an object that fell from the lunar landing module a distance of 80 meters to the surface of the moon. So start off just like on the last problem and find ordered pairs for these points. So 5, 20, 7, 38 is what I'm going to call it. Remember, we're just approximating these. This one is 8.5, comma 55, and then I could call this one 9.5, comma 71, and then the last one is 10, comma 80. Okay, and so let's just go and do a couple of these. I don't think I'm going to bother doing all of them. But what they want you to do is find the slopes of the secant lines, right? So that we already know how to do. So it's just delta y over delta x. So like if I did Q1 P to Q1, that would be 80 minus 20 over 10 minus 5. So that's negative, that's 60 over 5, so that's 20 meters per second. Okay, and then if we did the last one, for example, same idea, right? You guys should be able to do the rest of these. So the last one would be 80 minus 71 over 10 minus 9.5. So that's 9 over 0.5. So that's oh, sorry, I didn't. This one is not correct. This one should have been 12 meters per second. Okay, and then this last one, so that's 18 meters per second. Okay, and so we can see that it's increasing. So about how fast is the object falling when it hits the surface? Well, probably about 20 meters per second. Okay, so that's the idea of how this works. So thanks for watching this first lecture video. There'll be more to come. Make sure you're doing your homework assignments. You can feel free to reach out to me with any questions via email, phone, or text message. And make sure you get all your work done for this week. All the homework assignments and the weekly quiz.